Okay guys, we're back with 9.2. So we only have one vocab this time, thankfully. Okay, so simplest form. An expression is in simplest form when there's three conditions that have to be met. So an expression is in simplest form simplest form when, and there's three conditions. So I'm going to go ahead and move that down. And I'm going to write them over here just so I have more room. And I'll put an arrow. So the first condition is that no perfect square factors are in the radicand. And remember, the radicand is what's under the radical. That's the radicand. Okay, the second condition is that there are no fractions in the radicand. And the third condition is that there are no radicals in the denominator of a fraction. So we never want a radical on the bottom. And that one's actually really important, so I'm going to put a star by it. Okay, you can never have a radical in the denominator of a fraction. So those are the three conditions that have to be met to be in simplest form. Okay, so I'm just going to arrow over them to them right there. Okay, so now there's some properties of a radical. The square root of a product equals the product of the square roots of the factors. Sorry, I had to read my notes there. But the square roots of the factors. So the radical of a times b is the same as radical a times radical b, as long as they're both bigger than 0. I'm going to go ahead and highlight that because that's a really important one. Okay, next, okay, the quotient property is the same thing, okay, but dividing. So the square root of a quotient equals the quotient of the square roots of the numerator and denominator. So the square root of a over b is the same as the square root of a over the square root of b. And again, I'm going to highlight that. Okay. So now I'm going to scooch it up a little bit. You can pause if you're still copying. Simplifying the product property. So we want to simplify the radical of 27. So we need to remove perfect square factors. So I've been testing you on some squares on your mental math, so you should know some. But I'm just going to list a few we could use. We could use 4 as a perfect square of 2, 9 is a perfect square of 3, 16 is a perfect square of 4, then we have 25, I don't know what happened there, 36, 49, and it's actually, the list is endless. So 27, my first step is always to break it up into factors and see what might be two perfect square ones. Well, I immediately think of 9 and 3, and 9 is one of my perfect squares, so that should work out. So I have the radical of 9 times 3, since that is 27. So then I have radical 9 times radical 3 by the product property. So radical 9 then, well, that's a perfect square. Radical 9 is the same as 3. So then I just get 3 rad 3, and that is my answer. I'm going to go ahead and scooch it up. So now we have the quotient property. Okay, so by the quotient property, I have radical 5 over 16. So I can say that is just radical 5 over radical 16. And wow, one of those is already a perfect square, 16 is, so I'm going to change that 16 to a 4, and my simplest form is radical 5 over 4. Because I have no more perfect square factors to take out, and most importantly, I do not have a radical on the bottom. Can't have a radical on the bottom. But a radical on the top is okay, so we're going to leave it. So 48, well that's going to be kind of a tricky one. So let's think of 48 and list some factors. I know I have 24 and 2, but those aren't perfect squares. I have 12 and 4. Let's see if 3 can go in. Oh, yep, I have 16 and 3. So I know that 16 is one of my perfect squares. So I'm going to break that into 16 times 3. And I'm also going to break the bottom 75. Well, that one's not too hard. It's 25 and 3. And I know 25 is a perfect square. So I have 25 times 3. So then I can actually divide out the common factors. So I have 16 times 3, 25 times 3. Well, 3 over 3, they cancel out. So then I'm just left with radical 16 over 25. So then the quotient property tells me I can break that down into radical 16 over radical 25. Well, radical 16 is just a 4. Radical 25 is just a 5. So I reduce it to 4/5 as my answer. So now we're almost done with these notes. These were pretty not too bad. Okay. So now we have the checkpoint to simplify the expression. So here I have radical 12. Oops, sorry guys. Let me zoom out a little bit. Actually zoom in. There we go. I want to make sure this gets recorded. So now I have radical 12. So I gotta break 12 down. Okay. I know 12 could be a 6 and a 2. Or a 4 and a 3. Oh, and 4 is a perfect square, so I'm going to use that one. So I break it down into radical 4 times 3, which by the product property is radical 4 times radical 3. And radical 4 will just become a 2, so then I get 2 rad 3. Then I'm going to do one more for you guys. I'm going to do, let's see, look at number 4. So for number 4, okay, 48. We actually already broke 48 down. Actually, let's do number 3. Because number 3, I'm not sure number 48 is getting recorded. So number 3, we'll break that down into radical 13 over radical 36. Well, radical 36 is just a 6. So I'm left with radical 13 over 6. And nothing goes into 13, so I'm done. It's just radical 13 over 6. Okay, go ahead and try the rest of these. Actually, we'll do number 2, just so we do all the top ones. So number 2, 63. Let's see, what are factors of 63? Well, I know that there's 3 and 21, or 9 and 7, and I know 9's a perfect square, so that's the one I'm going to use. So I have radical 9 times 7. So I have radical 9 times radical 7. Well, radical 9 is just a 3, so I'm left with 3 rad 7. Okay, so now go ahead and try those on your own. They're not too bad, and that is the end of the notes. So pretty simple today.